to do today. So thank you very much for all attending. I think it's going to be a great hour, potentially a presentation, and another hour of networking, meeting everyone that's here. Welcome to WestGate First Tuesday event, or some may refer to it as the News Before Brews. The first Tuesday of each month, we design an opportunity for industry, academia, and government innovators to converge, share knowledge, develop networks, and have discovery opportunities. My name is Samantha Nelson, and I'm the program manager for the Purdue at WestGate here, housed within the WestGate Academy. I have a team member, Morgan Tavis, who is behind this web camera there. So she is another team member. Jason Sahlstrom is our director. I don't think he's in here yet. He's out talking. But before we introduce our first Tuesday presenter, we would like to provide some information on the newly established Upland Science and Technology Foundation. Bryant was recently hired as the CEO of USTF. And if you haven't heard of USTF, you will. Bryant will provide a short briefing, but in short, the entity was established to facilitate the transformation of WestGate into an innovative community. So, Bryant?
Thank you so much, Samantha, and to the entire team and to all of you for being here, and to the Reliable MicroSystems team for allowing me the opportunity just to say a few words about USTF. So many of you, if you have heard of USTF, great. If you haven't, as Samantha said, you're going to be hearing more. We are the recently established development organization specifically around exactly what you're saying. So it's just specifically around the tech park, working in lockstep with the three counties, with Davies, Martin, and Greene counties, and our regional stakeholders. So the Regional Opportunities Initiative, Radius Indiana, the IEDC, ARI, obviously NSWC Crane and SA Crane, and those folks to continue to build out the tech park into an innovation ecosystem right here in the heart of the Indian Uplands. So I'm thrilled to be here. This is my first Tuesday on the job. In these first few weeks to a month that I've been in the role, I've just been getting around meeting with folks just as yourself, right? I found that this is a great opportunity to network with tenants, with stakeholders in the tech park, to continue to build the brand of USTF, get our name out there and what we're trying to do in building that innovation community, streamlining the development process, making it simpler, smoother to do development deals in the tech park, but also aligning that with the vision that was outlined in the 2019 master plan for WestGate, right? And achieving that live, work, play environment that we all aspire to in this space. So the Purdue team has been wonderful in allowing me this opportunity just to share a few updates of what's happening with USTF. Obviously, this being my first month on the job, it's getting out and doing things such as this. So there will be more to come. Right now, we're working on branding, brand positioning, getting the name out there, setting up some meetings, and talking about what's next to come for WestGate, specifically as it relates to a lot of what you're going to be hearing about today, related to microelectronics. And if you were at the event with CRDG earlier today, specifically in that mission area, which is where we're seeing so much opportunity for the tech park, not only on a state level, but on a national level with the innovation ecosystem. So thank you so much for the opportunity. I look forward to connecting with all of you. I'm going to be here. If you have ideas, you have folks that maybe I need to get in front of, come and talk to me after the presentation today. And now our exciting guest, Lloyd with Reliable MicroSystems.
Like you said, I think you'll be hearing a lot about them in the news. We're pleased to have Lloyd Massengill here today. He is CEO of Reliable MicroSystems as our presenter this afternoon. Reliable MicroSystems has established a physical presence here at the WestGate Technology Park. They are going to stand up a prototype world-class integrated design service center. His presentation will describe the strategy critical disk at WestGate.
Hear me okay? All right, very good. Well, thank you, Samantha. It is a distinct pleasure and honored to be here today to talk with you about mission critical microelectronics for the DoD and for the warfighter. So yeah, my name is Massengill. I'm representing MicroSystems today. I'm going to take a moment and do a shameless plug, and then move on from that and get into more technical. A few words about the company. Many of you know me from my many years, I won't say how many, at Vanderbilt University as a professor, but today I want to talk specifically about MicroSystems, the company. So, and forgive me for referring to my tablet since the screen's behind me. I don't want to do this the whole time. I'm going to try to hold this in front of me with the screen behind me. So, Rel-Micro, we're a Tennessee-based company. We have a presence in Springs, which is a suburb about 12 miles south of Nashville, Tennessee. Are doing their mission-critical electronics, digital engineering for the DoD. But we're very excited, as was mentioned earlier, that was established in January 2023. So on the screen, what our mission is, and yes, I think it does show up. You can pay close attention to the highlighted sections. We are involved in radiation effects digital engineering, in models and simulation, modeling, design, and the implementation of fault-tolerant techniques. And I'm going to talk about those in detail in the coming slides. So we have combined expertise of many decades with Micro. In 2016, there were two of us, myself and my partner in crime, Jeff Capella. In 2020, there were four of us. We added Buckley here, our Chief Operations Officer. Many of you know Julia, and Grant Poe, and today we're 40. And so it's phenomenal growth. We're very excited about it. One of the things that I am personally most excited about, given my teaching and college professor roots, is the cadre of interns that we have. But we have 18 interns this year. I'm going to put them on the spot. If you're a Rel-Micro intern, hold up your hand. There you go. That's our future. That's what we're doing. It's in 3 parts. One is about 10 minutes, so don't freak out. It's okay, I'll try. Part 1 is a university lecture. And I know you're thinking, I didn't sign up for this, but you're a captive audience now, and I'm a college professor. So I'm going to do a little bit of a college lecture. Have no fear, I teach to the exam, which will be at the end, so prepare. Well, we're going to do that. I'm going to talk about 2 particular topics that play into the vision that I'm going to be talking about, and that's digital engineering and hardened microelectronics. And then after I give that background, I'm going to talk about the challenging path that we have ahead of us, why we're trying to do what I'm describing here today. Then part 2, I'm going to give you the concept of what we're establishing here at WestGate. I'm going to talk about the partnership we're building, the Integrated Services Center, and the components of that service center. Pardon me, I'm going to move this down. And then part 3, time permitting, technical activities that we have going on. So part 1, the landscape. So let me start with a definition. What is digital engineering? So a lot of words on the screen, but pay attention to the highlighted words, okay? And then I'm going to the highlighted words. This is not government definition from the Office of Under Secretary of Defense. Digital engineering, in its formal definition, is an integrated digital approach using authoritative sources of system data and models as a continuum. That's the word there, data and models as a continuum. Throughout the development and life of the system, digital engineering updates practices to take advantage of computational technology, modeling, analytics, and data sciences. So that's what it is, but what does it do? Digital engineering enables ways to accelerate innovation and transition R&D into manufacturing. And notice the last phrase there. It is critical to our national defense ecosystem. Again, not my opinion, the opinion of the U.S. government. So how is then this thing called digital engineering implemented? So, one strategy, there are others, but this is one. This is the strategy from the Navy and Marines Digital Systems Information that was signed in 2020. 5 major components. Formalize the development, integration, use of models, provide an enduring authoritative knowledge source, incorporate technological innovation to improve, establish and support the infrastructure and environments for digital engineering, culture and workforce. So, and look at the highlighted terms. And I'm going to come back to this in a moment. So remember, models, data, tools, and talent. Models, data, tools, and talent. And we will return to that in a few moments. That's the first piece of definition. Second piece of definition are mission-critical microelectronics. What are those? These are microelectronics where failure is not an option. The ones that are obvious to the group here would be weapon systems, nuclear power, mil-aero, and commercial space. But there's some others that perhaps we don't think about every day. Medical, automotive. Think about self-driving cars, autonomous vehicles. The electronics in autonomous vehicles are now life critical. And then high consequence IT, such as large data banks, server farm banks. You know, you don't want the bits flipping in the balance of your checking account, at least not in the wrong direction. If they went in the right direction, would be great, but that never happens. So harsh environments, radiation resiliency are foundational to this ecosystem of mission-critical electronics. So that's the second piece of the puzzle here, putting together our radiation effects and radiation microelectronics, radiation-hard microelectronics. All right, so what are radiation effects? So I thought, given all the news about AI and ChatGPT, I would ask ChatGPT, what are radiation effects? And I said, and I specifically, here's the question, concisely tell me what radiation effects are. This is what it came back with. I think ChatGPT may channel, but I call that verbose, it called it concise. But let's look at this definition. And actually, it's not a bad one. Radiation effects refers to the impact of electronic devices and circuits. When exposed to radiation, high-energy particles or electromagnetic waves, microelectronics can experience various detrimental effects. And it lists out a bunch of effects. Single events, upsets, all the things that those of us in our field study. It goes on to say there's permanent degradation or temporary degradation, total ionizing dose. Many of you in the audience know what that is and have studied that. And then the red keywords here. Understanding and mitigating these radiation effects is crucial for Rad-Hard microelectronics for applications in high radiation. So if you've never actually seen a radiation effect, you're about to here. This is a UV satellite image of the sun. Now, right there, those are radiation effects you're looking at. So the solar flare, and this is not a simulation, this is an actual image from a satellite. The solar flare emits particles, the particles interact with pixels in the generating the image, and the sensor misinterprets those as photons from light. And so it shows sparkles on the screen as the radiation interacts with the sensor. That is a detrimental radiation. But I asked AI, I asked Chat, what are radiation-hardened microelectronics? And this is what it came back with. A bunch of words, again, pretty verbose, but highlighted blue text. These microchips are engineered to be resistant to the damaging effects of ionizing radiation by employing specialized materials, designs, and manufacturing techniques. And then the red keywords here. Reliable and uninterrupted performance of critical systems in extreme radiation conditions. So reliable and uninterrupted performance is how we would define Rad-Hard microelectronics. And so how is this done? Well, there are several ways to harden circuits against microelectronics. First is just avoid the environment, which sometimes can be a that's one possibility. The second one that's not shown here is that's what's in your cell phone. So as microelectronics scale, a lot of ways they get better, they get harder to radiation because of Moore's law scaling. And some of the circuits in your cell phone are actually much more resistant to radiation than circuits are just happen. These three on the screen are areas where actual engineering Rad-Hard circuits and circuits. And so the three main ones are radiation hardened by process, where the actual fabrication process is modified, radiation hardened by design, where the circuit design is modified, but it is built in a foundry, so nothing is done in the process, it's all done at the circuit design level, and radiation hardened by architecture, which would be error correction, EDAC, that kind of thing. Radiation hardened by process is a very expensive proposition, and again, this is my opinion here only, but my opinion is the only viable business model for that is U.S. government support. Radiation hardened by design is what we do, and what many at the tech park here do, and many across the defense industrial base, where circuits are designed to be resilient, and then they're fabbed in a standard commercial fabrication. All right, so I've described radiation effects, I've described Rad-Hard electronics and what they are and how necessary they are to our nation. What is the DoD's posture on these Rad-Hard electronics? And so this came from a defense study that was part of the Defense Production Act in 2021. What I'm quoting here, sorry, there should be a quotes, my bad. And so there are a lot of words, but focus down on the blue text and the red text. Hardened and strategic Rad-Hard microelectronic components to support programs such as satellite and nuclear modernization effects. And audience are involved in those activities. Know how important Rad-Hard electronics are to those activities. And then the red text. Maintaining and expanding domestic capabilities, domestic is the key word there, for the production of radiation-hardened and strategic radiation-hardened microelectronic components is of vital national importance. So that is one of the reasons I like getting up in the morning, because I feel like the work we're doing, all of you in this room are doing, is impactful and important to our nation. What about commercial, new space? What's their posture on radiation-hardened electronics? Well, here we go. It comes from a market analysis study that was done in 2023. Increased dependence on satellite navigation and other satellite-based applications has resulted in an increase. Watch the news, right? SpaceX putting up satellites faster than you can keep up. And other space missions undertaken on a global level. However, designing a radiation-hardened electronic testbed is a complex procedure, to say the least. And focus on the red text here. With the advancement of technology and the proliferation of applications of radiation-hardened electronics, the cost of conducting extensive R&D for emerging applications is higher and does not ensure profitability in return. All right, so that is going to lead into the services center that I'm coming to. But one more definition. We asked ChatGPT, the fountain of all microelectronics. The United States has traditionally been considered a leader in Rad-Hard microelectronics. And then look at the next blue text. The U.S. government, along with various aerospace and defense companies, has invested significant resources in research, development, and production of radiation-hardened microelectronics. And the red. However, it's worth noting that other countries, such as Russia and certain European nations, also have expertise in Rad-Hard microelectronics. What I found most interesting about this statement is not what's in it, but what is not in it. I don't know if that was by design or if that was just happenstance on the search algorithm of the internet, but I found it very interesting because not much in this area. So here's two of the particularly challenging. Focus on the left first. One of the problems with Rad-Hard design is it's very fragmented because it's a niche market. Companies do not have the resources to to do Rad-Hard design. And so, therefore, it's usually one or two people that are subject matter experts at a company, and it is fragmented across the defense industrial base. And then focus on the right. Market analysis study that was done again in 2023 looks at the market size. And notice it says that the largest market is North America, but in the circle, the fastest growing market is Asia Pacific. China is catching up very, very fast to this. So, here's the bottom line of what I'm pitching here. What our warfighters and our strategic systems and the new systems that are coming down the pipe, what they need are Rad-Hard chips that perform like a Ferrari. What they don't need are minivans. And so, keeping up with the technology, keeping up with the most advanced technology nodes is something that we're very interested in supporting, and that's part of why we're here at WestGate and why we interface with the Defense Industrial Base and for the Integrated Services Center that I'm. So hopefully I have laid the groundwork of what is needed and why we're trying to do what we're doing. So what's the battle plan going forward? Let's talk about a concept. Since we have this fragmented market and we have definite national strategic needs for Rad-Hard microelectronics, what is a path forward? So what we're interested in doing at Rel-Micro, something we've been working on for a couple of years now, is developing private, academic, and government partnerships to empower Rad-Hard digital engineering. Now note the word empower there is important because we're not establish a design center here that will do all the Rad-Hard designs for the country. No, no one can do that. No one should try to do that. What we want to do is provide empower those that are doing Rad-Hard design to do it better and faster. So you see some of the reasons there for doing this: the economies of scale, the power of collaborations, focus on common mission, and then efficiency and risk. Here's the vision. What we are working on is a Rad-Hard Design Integrated Services Center, provides access to modeling, radiation hardened design engineering, Rad-Hard by design infrastructure, to partners across the DoD and defense. In addition, our Integrated Services Center will coordinate across by providing access to intellectual property, R&D tools, testing infrastructure, and verification and validation assessments. So that's the kind of the general plan. Here's a more pictorial view of the Design Integrated Services Center. So the government use repository that includes things like test data, models that users can use, Rad-aware PDKs, process design kits that are used to design ASICs, and then design tools to help designers build better circuits. All that is in a repository that's available to the DoD. And then that flows out to Rad-Hard engineering expertise and training that also flows down to fault and failure assessment for the government. So the government can do risk reductions based on information coming out of this prototype. And so here's how the connectivity goes. It's color-coded here. Sorry for a little bit cartoonish. But the training ties into workforce development, the Rad-Hard engineering expertise that goes out to DIB performers, and they're doing Rad-Hard design. Fundamental academic research flows in to this services center. Purple you see there. There are commercial tool vendors that provide tools that are enhanced for doing Rad-Hard design, and then this information flows out to the decision makers in the DoD. That's the concept of the let me tell you a little bit about what we are doing here, how far we've gotten with this concept. Particular support strategic design services and the DoD. What we're doing right now is we're providing radiation testing and generating data. We are providing Rad-Hard design techniques, design automation tools, technology characterization, and you can a lot of activities going on here from a technical perspective at Rel-Micro. But what about this concept of an integrated design center? So it's certainly not just us. We are trying to facilitate this, but obviously it's much bigger than a company called MicroSystems. And so a first phase of this is actually being constructed right now. It's a relationship between Indiana University, Rel-Micro, and our partners, and it's busy. I'm not going to spend. Know that there's overlap between RMS in terms of interns, which we'll get to in a moment. There's overlap between IU and the DoD in terms of policy, in terms of basic research, and then there's overlap between the DoD and RMS in terms of R&D and providing tools and techniques. That's one concept, not the only concept, obviously. But that's one that is underway right now, being headed out of IU. And then we're also in the process of coalition building, and you see logos here. So there's a coalition. And I've just mentioned IU, but there's Purdue. We're standing in view. All at this point are cadence, but there are others coming online as we speak. Primes that we're working with presently and expanding very rapidly, so I don't want to leave anyone out here, but we're working right now with Draper and Booz Allen. The government agencies we're working with, of course, NAVSEA Crane, a primary supporter of this activity. IWIC facility out in San Diego, and there's office. And then the businesses that you see there, others, I'm sure I'll left someone out, and I apologize if I did, but there are lots of businesses that in coalition building is going on there. How am I doing on time, Julia?
You're good. Just about 15.
So, third part, I thought I would take a few moments to talk specifically about some of the technical activities going on at Rel-Micro. Remember, I said earlier, there was four aspects. There was data, models, tools, and so at RMS we are trying to tackle all four of those at various degrees. As I'm going to go through now relate to this for first data. So we have been now in designing very specialized technology characterization vehicles that are fabricated in the most advanced technology nodes that provide information that inform our models. And so these RTVs or TCVs, as we call them, or radiation TCVs, you see listed here some of our partners on this activity, and certainly highlight many of our partners without which this wouldn't be possible. For example, Draper. A lot of the fabrication of advanced technologies that we've done has been through our partners at Draper, and I want to thank them for that. We have partners in the small business realm, Scientific. Working with them. Boeing, Sandia, BAE, all of this STI, ASU, all of those partners. So this has been an activity to build test chips that will generate the data that models that flow in. Important aspect, because models are no good without data. They have to be calibrated to data. And simulation, also no good without data. Flowchart shows you pictorially some of the chips that we've been working on. The latest that we call Yellowstone 3 is in the 12 nanometer technology at Global Foundries, and that just taped out about 2 weeks ago. But you can see going back in time, we have quite a few tests fabricated successfully. The ones on the left-hand side of the screen we're actually testing now, and we'll be doing more testing on the ones to the right-hand side of the screen. And as they become available, they're fabricated, they come back to us and they're packaged. Into what is happening in the technologies as they scale to these small. That's vital if we want to achieve the earlier mission of giving the warfighter the most advanced technologies that. Now, models. Developing Rad-Hard or radiation-aware models for single event effects, TID effects, and prompt dose rate effects. Models fit into a normal EDA design flow that empowers a circuit designer to not have to be a radiation physicist. And so, brings us to my next topic, one that I'm very excited about, working on for quite a few years now, actually. Modeling information, the academic information, the data into a circuit designer that's working at a DIB partner that doesn't want to be, I want to be a physicist, he wants to. And so what are the challenges to doing that? The challenge is that radiation is a microscopic effect. But the effect of the radiation is a function. There's a large valley between those two. That valley has to be spanned in order to allow radiation effects to be properly modeled at the functional level. Point design space. Microscopic scale to state variables at the circuit level. I don't like to think about too much. Energy bands to Things are very far apart. But radiation operates at the low level, and the circuit operates at the higher level. Chip designers typically are not radiation physicists, and that's the bridge we need to span. One of the activities we had going on that I'm very excited about is something called Rad-Hard. Vertically integrated radiation aware design was an STTR that kicked off the company in 2016. It was funded by DITRA. We've been working on it ever since then. We're very excited about it. We're getting ready to alpha version of this capability. And you see here in this slide what the capability is. It uses a bottom-up approach in order to percolate radiation effects from these low level, from the microscopic scale, up to the circuit and system level scale. Engines that come out of the EDA community. Vitally important because I've been in this business for decades. I know circuit designers will not use a tool they don't like. And they will not use a tool that they're not familiar with. They do not want to learn a new tool. They want to use a flow, a digital engineering flow that they are comfortable with and they understand. And that's circuit design. And so for the first time, Rad has combined schematic level response and physical response without TCAD. Without TCAD is a key term here because that's not practical for our circuits. Rad is. So here's the development of Rad. You can actually see it running up in the upper right. So designer import from a standard CAD tool such as Cadence, import his design, import his layout, and then do radiation analysis on the layout and the circuit. And find hotspots in the circuit, identify failure modes in the circuit, and get instant feedback on his design as he's working through his design. And this is all seamlessly integrated within the Cadence workflow that a designer is familiar with and is comfortable with. And then, as I said, we're getting ready to release an alpha version. We have our partners coming in to Rel-Micro in Cool Springs, actually in 2 weeks.
Gosh, yeah, 2 weeks.
2 weeks. And so we're going to be kicking off that and doing a workshop and training session. Excited about that as well. I want to wrap up with this. Workforce development. You remember the four aspects that I was talking about? The models, data, tools, and talent. I've talked about models, I've talked about data from our test chips, I've talked about tools, Rad is one of them, but there are others. The talent. Workforce development, talent. Something that's on the lips of many in the community. Government as well, the DoD as well. Workforce. We've been engaged in workforce development. Several of us come out of academia, so mentoring young people is in our blood. Naturally do and enjoy it very much. And so we have, over the past, this year we have 18. Very proud of that, very excited about that. You see their bright shiny faces in the picture there. One's in the upper left or up here at WestGate, one's in the lower right. Find these young people from, it's all over the Southeast. Auburn, Georgia Tech, IUPUI, Lipscomb, Purdue, Rose. Often come up to me knowing my background at Vanderbilt say, oh, all your interns coming from Vanderbilt. No, coming from all over. And we're very excited about that, training up the next generation. In 2021-22, we had 11 U.S. trains, and just to our metric of success is out of our group of interns, the ones that graduated last year, those 4 young people are now supporting the DoD and the nation because of the internship program. Well, I hope partially because of the internship program at Rel-Micro. I would not want to claim all the credit for that. Excited about that and want to keep that going up here as well as down. And then something else that has been going on that we are quite excited about. Over the past 2 years, we've been sponsoring Middle Tennessee robotics programs. And this has been very exciting for our engineers, for our interns, and for the high school students. So we've provided physical space, we've provided some engineering guidance to these young people on these teams. 2 teams that we have been supporting, Ravenwood High and Brentwood High, and then next year we'll be sponsoring a team at Franklin High, all local schools in the Middle Tennessee area. And you see there their accomplishments. So 3 of the 4 teams of robotics championships, and then 5 of the 8 teams advanced to worlds from Brentwood High. One of those teams actually won their division. My partner, Jeff K. So they won their division in Worlds and came very, very close to winning the entire thing. So we're very proud of them. They worked very hard. But this is a way clubs in the high schools to K through 12 and engage, excited and interested in engineering. So anything that help do that, we are trying to do. I'm very excited about that. And then also you see there in the last bullet, STEM outreach through other groups, day camps and clubs. We help with the day camp for girls to explore STEM. There was a summer robotics camp that we helped support, and there was a summer STEM camp. That, I'll wrap up. That's my contact information. Out to us, have any ideas, we're open to improvements to this vision, as I'm calling it, for this integrated services center. Ideas. I will turn the podium over to Samantha and open up to questions. Thank you very much for your attention.
Questions for me right now? Step up and ask now. Or you could wait and have a drink and talk. You don't talk.
Standing between a group and be.
Our second microelectronics first Tuesday event, and this is, even in layman's terms, I don't know anything about microelectronics. I know I'd have to bring somebody here to talk about it, but he puts it in layman's terms. The other gentleman we had here put it in layman's terms. I think if I go to my hometown in Lagodi and talk, I think they think I'm a genius, so, because I know about it. But again, thank you, Lloyd, very much for coming. You've heard that microelectronics is definitely something that Indiana is investing in, so especially at Westgate. So we appreciate everyone that's come here to understand what's happening here at Westgate. If you're here last month, I introduced you to Thomas Fowkes. He's the CEO of Packergy, and he spoke for about 5 minutes regarding potential teaming opportunities. So I just want to let you know that he's going to have a table outside with a whiteboard and monitors, and he's going to talk your ear off in terms of those teaming opportunities. But if you're interested, please stop by. He's a very intelligent, ambitious young man who would love to be able to tell you what he's doing and what opportunities are out there. Lastly, we also want to thank Sweet Maple Realty and Weininger Construction for sponsoring this afternoon. So they are taking care of the food and one drink for you, which we also have pop and water out there. For coming. They will actually have a table outside. If you don't know who they are a realty company, a construction company that is invested in putting homes here within the WestGate Tech Park, just down the road in Scotland, Indiana. So they are
the promo.
Oh, they do have a promo outside. They have demonstration about a $10,000 closing costs, or $10,000 that you're going to get back at closing costs. So, but anyway, they have multiple homes that are being built right now, and actually a couple of them I think reliable employees have invested in. So I think that they're very nice. If you do have the opportunity, take a ride down the street and take a look at it. But there is information going to be out here. Shane Gibson with Sweet Maple Realty will be out here, as well as a couple other people from Weininger Construction. So thank you again for sponsoring and coming. It's interesting that he talked about the ChatGPT, because we are actually going to host a webinar next week on ChatGPT in the defense industry. We have found a couple research associates out of the George Mason University and Georgetown University in DC, specifically on ChatGPT and other forms of AI in terms of the defense industry. I found that they had written an article that was very interesting, and of course it's all timing right now, right? So it's going to be very interesting. So let us know if you want any more information. It is on our website. I think that's all. So make sure you go to our website and check it out. We have a lot of other things that we continue to have up. We're going to have another First Tuesday, obviously, with some other microelectronics and some. Now for the fun part. Thank you all for attending today. Thank you very much, Lloyd, for coming this way. Julia, you've been instrumental in becoming here and being a partner. Reliable, obviously you can see how fast growing they are and how ambitious they are. Love that the interns are here. Oh my gosh, I love this. Love productive conversations, and I look forward to speaking to you out there.